All right, the second video is for problem 2A from the 2012 option test. It is a problem concerning using Euler's method. Now, the Euler's method formula is given on the option test formula sheet. Now, the way they write it is like this. Y sub n plus 1 equals y sub n plus h, and then times, use an x for the time symbol, f x sub n comma y sub n. Now, f x sub n, y sub n stands for the function of the derivative. It's a little confusing. When I use the formula, I've seen it before written with the prime sign, so you understand that that is the derivative that's given. So I'm going to put the prime sign in there, even though it's not on your formula sheet. Understand that that stands for the derivative. Now, we want to find, evaluate, approximate x equals 0.5 with a step length of 0.1. The step is your value of h, so that is 0.1. It says that the initial x is 0, so x sub 0 is equal to 0, and the initial y is 1. Okay, so we need that information to get started. So applying L'Hopital, the first step, y sub n plus 1, which means the next value of y is equal to the previous value of y, which is 1, plus h, which is 0.1, times the derivative using the previous x and the previous y. So what you do is you sub in the previous x of 0, the previous y of 1 into the derivative formula, which is y squared over 1 plus x. So it'd be y squared, 1 squared, over 1 plus x. X is 0. All right, now all you have to do, since this is a calculator problem, is just punch that in, and that turns out to be 1 and 1/10. Now, that is the first step, using the previous x of 0. So this would give us the value of x equaling 0.1, since the steps are 0.1. So the next step would be when x equals 0.2. So it's just a repetition of the previous formula. So the next y sub n plus 1, equals the previous y. Well, the previous y is the previous result of 1.1, plus h, which is still 0.1, and then times the derivative evaluated using the previous x and the previous y. Well, the previous x, we remember we started with the x of 0, so the previous x is now 0.1 since we went up by a step of 0.1. So it's y squared, which is 1.1 squared, over 1 plus the previous x of 0.1. And again, just punch that in, and that turns out to be 1.21. All right, just a couple more, well, actually 3 more steps to go here. So the next step will put us when x is 0.3. So the next y is equal to the previous y, 1.21. You just look up the previous step, times plus h, which is 0.1, and then times the derivative using the previous x and the previous y. Well, the numerator is y squared, so that's going to be 1.21 squared over 1 plus the previous x was 0.2. So again, we just evaluate that, punch in 1.332. 332 is what my calculator is saying. Next step, x equals 0.4. Now that's what we're trying to evaluate, x equals 0.4. So we're going to use the previous x again in our formula here of 0.3. So using the formula, previous y is 1.332, one we just found, plus h, which is 0.1, and then the derivative evaluated with the previous x and y. So it's just a repetitive process here. The previous y is 1.332, and we are going to square that over 1 plus the previous x of 0.3 will give us the answer of 1.468. All right, last but not least, final step, we're trying to evaluate x equals 0.5 using formula, y sub n plus 1 equals the previous y, a plus h point 1 times the derivative evaluated with the previous x and the previous y. Previous y, 1.468 squared over 1 plus the previous x, 0.4, equals 1.62. We have solved problem A. Final answer, 1.62, which gives us what? 7.7 marks. Yes, very good.